After we learned how to calculate the center of gravity measured in inches on our 727, the next step we looked at was this thing called the mean aerodynamic chord and the leading edge of the Mach, and determining what percentage of the Mach was covered by that new center of gravity that we calculated. So in here we'll examine that. But a little reminder of some terminology. The LE Mach value, the leading edge distance to the Mach, is measured from the datum to the leading edge of the wing where the Mach resides. And if you're not sure how we found where the Mach is, we have a separate video that illustrates that. The Mach is the distance from the leading edge to the trailing edge based on some other calculations we did. What we need to do is find out what percentage of that Mach is reached with the center of gravity. So, calculation for that, percentage of the Mach, the center of gravity we calculated, measured in inches, minus this distance, leading edge back distance. So my CG, measured somewhere around here, I'm going to take the CG and subtract the leading edge back. What that means is, I'm really coming up with that distance, how far down the center of gravity goes along the Mach. And I'm sorry if those lines aren't quite parallel, it's freehand, but you get the idea. So my center of gravity came a certain distance past the leading edge of the Mach. I'm calculating that difference. That's what that top line is, CG in inches minus the LE Mach, divided by the Mach. So we're going to take this distance, divided by the total Mach distance. That'll give me what percentage this is of the total, hence percent Mach. So let's look at an example. If I calculate the center of gravity of 917 inches, and the plane had a total weight of 127,000 pounds on board, that's the aircraft plus all cargo and flight engineer and pilot and all that, what is the percent Mach value, and is this plane okay to fly? There's two parts to that question. Well, first, let's get the percent Mach. My CG I calculated was 917 inches, subtracting 860.2 inches. For our plane, that's an approximation of the value. I don't have the manual, so I don't know the exact number, but that's the number that I found. It seems about right when I do some measuring. 860.2 inches is the leading edge distance to the Mach. The Mach is 180 inches. That's the distance from the front end, the leading edge to the trailing edge of the wing at the Mach. So, 917 minus 860.2 will give me the difference between the leading edge Mach and the CG, so that'll tell me this distance, how far into the Mach it is, divided by the Mach distance, 56.8 inches, divided by 180 inches, gives me 0.315. As a percentage, remember this is a percentage, so 0.315 would be 31.5%. For our purposes for looking things up, that's roughly equal to 32%. So now the question was, is it okay to fly? I've got the percent Mach at 32%. Is this plane okay to fly? Well, I included a chart that looks kind of like this. I've, again, put a freehand drawing, but it kind of looks like this. The percent Mach value along the bottom, 10, 20, 30, 40, 50, 60%, and so on. And the weight in thousands of pounds, 90,000, 110,000, 130,000, 150,000, and so on. So I cross-reference that. My percent Mach was 32, so that's roughly here. My weight, 127,000 pounds, roughly there. If I find the intersection point of those two, it's roughly here. That is inside of the chart. Because it's inside, that means the plane is okay to fly. If the intersection point fell outside of that diagram, then it would not be okay to fly. So in this case, 127,000 pounds, 32%, we're good to go.